All right, so if you're building with LLMs, you know the goal, right? You want systems that are smart, fast, and most importantly, reliable. But what if I told you that the most successful teams out there aren't using these super complex, tangled frameworks? Nope. They're actually using simple, elegant patterns to get incredible results. And today, we are going to dive into one of the most powerful ones. So, let me ask you, does this scenario sound just a little too familiar? You've got this one single large language model, and you're throwing a massive, complex task at it with like a dozen different constraints. You need it to be creative, but also super safe. You need it to be fast, but also incredibly thorough. And what do you usually get? A system that's slow, full of errors, or, just completely gives up. That's the one model bottleneck, and it's a trap so many of us fall into. And this right here, this quote from Anthropic, it hits the nail on the head. The real breakthrough isn't about building one bigger, more complicated model call. The magic is in breaking the problem down, using simple, modular patterns that you can piece together. It's all about building smarter, not just bigger.
Okay, so we've talked about the problem. Let's get to the good stuff, the solution. The hero of our story today is a pattern that takes that single overworked model and replaces it with a whole team of specialists. Let's meet the parallelization workflow.
So, what is this thing, really? At its heart, parallelization is just about divide and conquer. Instead of one LLM call trying to juggle 10 different jobs at once, you give several LLM calls each their own single, focused job to do, and they all do it at the same time. Then a little bit of code just pulls all their work together at the end. The result? Well, each individual call is way simpler, it's more accurate, and the whole system just gets a whole lot faster.
Now, this pattern isn't some one-size-fits-all solution. Not at all. It actually comes in two pretty distinct flavors, and each one is perfectly suited for a different kind of challenge.
So on one hand, you have sectioning. You should think of this as your specialist team. You've got an analyst, a compliance officer, and a translator all working on their own part of a project, all at the same time. Then, on the other hand, we've got voting. This is more like a panel of judges. You ask several models the exact same question to see if they agree, which helps you find the most reliable answer and catch any weird outliers.
All right, so let's put this specialist team approach to the test. Let's see how sectioning is being used to solve some really tough real-world problems in two totally different industries, finance and e-commerce.
First stop, finance. Now, in an industry where speed and compliance are absolutely non-negotiable, managing risk in real time is a huge challenge. And this is a perfect job for sectioning.
So picture this. A customer asks for some pretty complex investment advice. With sectioning, that one query kicks off two specialist models at the exact same time. Model A gets to work generating the actual investment options, but simultaneously, Model B is acting as a guardrail, screening that same request for any compliance risks or regulatory red flags. The system then brings those two outputs together, making sure the final advice is not only helpful, but also 100% compliant.
Okay, now let's jump to a completely different world and see how this same pattern works in e-commerce. Here, the name of the game is creating personalized marketing content at a massive scale, and you have to do it fast.
Imagine you need to launch a new global ad campaign, like yesterday. A single prompt can fire off multiple LLM calls in parallel. One call is busy writing that awesome marketing copy in English. At the exact same moment, other calls are translating that copy into Spanish, French, and German. And here's the kicker. Your entire multilingual campaign is ready to go in the time it takes for just the longest one of those tasks to finish. That is a massive speed up.
All right, let's switch gears and talk about our second flavor, voting. Remember, this one is all about boosting your confidence and accuracy by getting multiple opinions from your panel of experts. Okay, for all you IT professionals out there, this is a classic and it is a critical one, code review. We all know that a single missed vulnerability can be absolutely catastrophic, so getting a second, third, or even fourth opinion on your code is incredibly valuable. So instead of one general prompt to just find bugs, you run multiple specialized reviews in parallel. Voter 1 is your SQL injection expert. At the same time, Voter 2 is on the lookout for any authentication flaws. And Voter 3 is checking for insecure dependencies or outdated libraries. Then you aggregate the results. If any one of them raises a red flag, the code gets rejected. Simple as that. It creates a much more robust security net. Now let's apply this to a field where accuracy can literally be a matter of life and death, healthcare.
Analyzing clinical notes for sensitive information is an incredibly high-stakes task. You just can't afford to get it wrong.
So when a doctor's unstructured note gets submitted, you can have 3 separate LLM instances review it all at once, looking for things like protected health information or PHI leakage. Then you can set a simple rule. If 2 out of the 3 models flag the content, it gets escalated for human review. This voting system is just a brilliant way to balance that tricky trade-off between catching every single potential error and, on the other side, avoiding a flood of false alarms.
Okay, so after seeing all these examples, what's the big payoff here? Why should you, as an IT professional, really care about this pattern? Well, it all boils down to 3 things: making your systems smarter, faster, and giving you way more confidence in what they produce.
And what's great about this is how clearly it lays out the benefits. Let's just look at the comparison. Speed? With the parallel pattern, you're only as slow as your single longest task, not all of them added up. Accuracy goes way up because each model has a simpler, more focused job. And your confidence in the final result? It's so much higher because you've gotten rid of that single point of failure.
So the crucial takeaway here is this: stop trying to build one giant, all-knowing AI brain. It's just not practical. Instead, start thinking like an engineering manager. Your job is to build and orchestrate a high-performing team of focused, expert agents that all work together to get the job done right.
And that leaves us with one final question for you to take back to your own work. I want you to look at the biggest, most complex challenge you're trying to solve with AI right now. Now, what would it look like to stop thinking about it as one big problem and instead start thinking about how you could build a team of specialists to tackle it in parallel? The answer might just be simpler and way more powerful than you think.